So let's start with the deep learning. This is one of the most important topic in artificial intelligence and machine learning. So deep learning is a computer software that mimics the network of neurons in a brain. It is a subset of machine learning and is called deep learning because it makes use of deep neural networks. Before we go on to learn the deep learning, let's first try to understand what is neural network. A neural network is a series of algorithms that endeavors to recognize underlying relationships in a set of data through a process that mimics the way the human brain operates. Neural networks can adapt to changing input so the network generates the best possible result without needing to redesign the output criteria. Now, as we know, deep learning is a subset of machine learning where artificial neural networks are inspired by the human brain. These neural networks further analyze and accumulate insights from that data and later learn from the same. Deep learning algorithms are constructed with connected layers. The first layer is called the input layer, the last layer is called the output layer, and all layers in between are called hidden layers. The word deep means the network joins neurons in more than two layers. Deep learning, in short, is a part of family of machine learning methods which are themselves a subset of the broader field of artificial intelligence. Deep learning is a class of machine learning algorithm that use several layers of non-linear processing units for feature extraction and transformation. Each successive layer uses the output from the previous layer as input. Deep neural network, deep belief networks, and recurrent neural network have been applied to fields such as computer vision, speech recognition, natural language processing, audio recognition, social network filtering, machine translation, and bioinformatics, where they produce results comparable to, in some cases, better than even human experts. We know that deep learning consists of hidden layers, and each hidden layer is composed of neurons. These neurons are connected to each other. The neuron will process and then propagate the input signals it receives from the previous layer. The strength of the signal given the neuron in the next layer depends on the weight, bias, and activation function. So basically the previous layer pushes it, gives the necessary weight so that the next layer takes over and then works for the further next layer. Deep learning process, a deep neural network provides fairly good amount of accuracy in many tasks, from object detection to speech recognition. They can learn automatically without a predefined knowledge explicitly coded by the programmers. So let's first try to understand the neural network. Now, what is neural network? As already explained, a neural network is a series of algorithms that endeavors to recognize underlying relationships in a data or in a set of data through a process that mimics the way the human brain works. In this sense, neural network refers to systems of neurons, either organic or artificial in nature. The network uses large amounts of input data and operates them through multiple layers. The network can learn increasingly complex features of the data at each layer. Neural network can adapt to changing inputs so the network generates the best possible result without needing to redesign the output criteria. The concept of neural network, which has its roots in artificial intelligence, is gaining popularity. So you can see the structure of the neural network would be something like the picture that you see on your screen. We know a neural network works similar to the human brain's neural network. A neuron is a neural network, is a mathematical function that collects and classifies information according to a specific architecture. The network bears a strong resemblance to statistical methods such as curve fitting and regression analysis. The neural network contains layers of interconnected nodes. Each node is a perceptron and is similar to a multiple linear regression. The perceptron feeds the signal produced by a multiple linear regression into an activation function that may be non-linear. Now, in a multi-layered perceptron (MLP), perceptrons are arranged in interconnected layers. The input layer collects input patterns. The output layer has classifications or output signals to which input patterns may map. For instance, the patterns may comprise a list of quantities for technical indicators about security. Potential outputs could be buy, hold, or sell. Now, hidden layers fine-tune the input weightings until the neural network margin of error is minimal. It is hypothesized that hidden layers extrapolate salient features in the input data that have predictive power regarding the outputs. This describes feature extraction, which accomplishes a utility similar to statistical techniques such as principal component analysis that we already studied in the earlier tutorials. Now, applications of neural network. Neural networks are broadly used for financial operations, enterprise planning, trading, business analytics, and product maintenance, etc. Neural networks have also gained widespread adoption in business applications such as forecasting and marketing, research solutions, fraud detection, and risk assessment, etc. So you can see some of the applications which are mentioned on your screen. A neural network evaluates data to unearth the secrets for making decisions with appropriate data analysis. A network can distinguish nonlinear interdependencies and patterns, which other methods probably find it difficult to analyze. Researchers claim the accuracy of neural networks in making price predictions for stocks. Some models predict the correct stock prices and some are not. So that is how ANN can be used. Now it depends how good is your model, because if your model is good, you can expect a good result. Both the algorithm as well as the data help determine the level of success of a neural network. Thus, emphasis must always be given to accurate input data, then a good algorithm does the remaining job. So both the data should be accurate and of course your algorithm should be good. Both of them, if they are good, definitely you expect a good result. Now, in neural network, each layer represents a deeper level of knowledge, that is the hierarchy of knowledge. A neural network with 4 layers will learn more complex features than that with the 2 layers. Obviously, more layers mean that you are going to be more in detail, and that is why your expected results would be better and better. So, learning occurs in 2 phases. The first phase consists of applying a non-linear transformation of the input and create a statistical model as output. The second phase aims at improving the model with the mathematical model known as derivative. The neural network repeats these 2 phases hundreds to thousands of times until it has reached certain level of accuracy. The repeat of this 2 phases is called an iteration. Classification of neural networks. Shallow neural network. The shallow neural network has only one hidden layer between the input and the output. And deep neural network have more than one layer. It may be 2 or even more than that. For instance, Google LeNet model for image recognition counts 22 layers. So that depends, because the more layers you have, more accuracy is going to be there. Deep learning is used in many ways, like driverless cars, mobile phones, Google search engine, fraud detection, TV, and so on. So let's try and understand the deep learning in somewhat more detail. Artificial intelligence is getting the boost because of the deep learning. Applications wherein neural network plays a vital role in making it successful. The 3 main technologies work for deep learning are ANN, that is artificial neural network, CNN, that is convolution neural network, and RNN, that is recurrent neural network. So these are the types of technologies that we are going to learn in more and more detail. Thank you.